Hey guys, today we are going to demonstrate how we get through the fourth lab of EE 542, and this is our topology. As you can see, we create two nodes A and B, and we create a link here. The bandwidth is 1 megabits, and this is the delay. The round trip is going to 25 milliseconds, and we assign the operating system for those two nodes, and also we pre-installed iPerf 3, and we can also use the Emulab iPerf as well. They do actually give the same result, as you can see in the later slides. So this is when we are swapping our experiment. As you can see, we have like two nodes and bandwidth and delay, and the loss rate is going to be 1 in a thousand. And this is how we start our server, and we make the server listen on the port of 1 2 3 4 5. And this is our client side codes. As you can see, we trying to increase the size of the data we trying to send. You can see there's 0.93, 0.95. We found out that we lost the first packet at the 0.96. So that's our actual bandwidth in this experiment. This is how we send a data at the size of one megabytes. So we observe that we lost two packets. So the maximum bandwidth is around 0.96, which is pretty close to the bandwidth we set. So next is TCP throughput. So we tried the window size of 128, and the average throughput we got is 973, as you can see here. This one we use Emulab iPerf, which give kind of like the same output as we use iPerf 3. So next, we actually increase the bandwidth of the link to be 10, and as you can see, the result is still around 1 megabit. So the actual bandwidth is still around 1 megabits. And for the throughput, we still use the same window size, 128. The throughput is going to be 9.39 megabits per second. And the third one, we increase the maximum bandwidth to 100 megabits, and we still got the same result, as you can see here. So right, you can see we lost our first packet at 1.5 megabits. So we also tested the throughput for the situation where our maximum bandwidth is 100 megabits. The throughput is like 14.7. So this is what we observed from the experiments. We found out that the maximum bandwidth stay around 1 megabits when we change the maximum bandwidth of the link to be 1, 10, 100 megabits. We think the reason why we have this result is that we fixed the loss rate to 0.01 for example, if we change for the experiment with the bandwidth equal to 10 megabits, if we change the loss rate to 0.001, the maximum bandwidth is going to be around 10 megabits, which is like the perfect situation. So this also applies to experiment which has a bandwidth of 100 megabits. So we can confirm that the fixed loss rate is one of the reason, and this is not going to happen in the real situation. And right, because we cannot have a fixed loss rate. It's like the loss rate really depends on the bandwidth of and the delays. For the TCP throughput test, we also tried the window size of 16, 32, 64. We found the increasing window size will increase the throughput, but there will be a maximum for the window size. Once we reach the maximum, the throughput will never be increased significantly. So right, and the default window size is 64. So this is the result table for us when we are trying to change different window sizes. As you can see, as we so the experiment will reach the maximum at when the window size is equal to 64. So as you can see here. So for the experiment with 100 megabytes bandwidth and 25 millisecond delay, the theoretical optimal window size is going to be 64K, and we don't get the 100 megabits throughput. We think there are multiple reasons. First of all, our delay. If we decrease our delay to 10 milliseconds, the throughput will be 20.5 megabits per second. And since we do fix our loss rate, and this could also be one of the reasons why we cannot reach 100 megabits, right? So this part is in the second link, right? So let's go to the second section. As you can see, we start the experiment with 100 megabytes and 5 seconds delay, 5 millisecond delay, and we swap in and we change the delay to 0. As you can see, this is the result. After the delay was set to 0, the round trip delay is going to be around 0.4 milliseconds, right in those pictures. And the maximum bandwidth is going to be 94.7 megabytes per second. And right, the bandwidth delay product is going to be 38.28 kilobits. So this is how we create and mount a temporary local file system. We use this command, and we in our node 0, we enter the folder, we enter the directory of MNT, and we do this command to create the data, and we use this scp command to copy the data to node 1. As you can see, this is like the speed we have, the throughput. So we change the delay, and we don't have any impact on the threshold. So next thing we did change some maximum window size from half megabytes to 1 megabyte and 2 and 4 megabytes. So you can see that the throughput initially increased, as you can see here, from 9.1 to 9.5 to 11.1, and this is when the window size is 1 megabits. So as you can see, after this, even you increase the maximum window size, the throughput is not going to increase anymore. So from what we observed from the previous experiments, so we found the throughput reaches peak when the maximum window size is equal to 1 megabyte. So we can guess the SCP has a built-in limitation for the window size. So since SCP is based on OpenSSH, so we think this limitation might be from the OpenSSH SCP configurations, and the limitation is going to be 1 megabytes. And after we check the references, SCP and SFTP has a built-in 1 megabytes buffer, which confirm our guess. So this is our next experiment. We're trying to increase the loss rate, and the threshold seems to be decreasing, pretty linear, but it's not perfect linear. And if we increase the packet loss rate, so since we don't, so it's pretty reasonable that threshold will decrease, since it will take longer time to send all packages when we lost more. So this is when we want to first of all we use this website to check. This website will make a ping between Los Angeles and Switzerland. So this is the delay we have, and if our friend is going to ask for a suggestion, so we will suggest him to adjust his window size according to the bandwidth of the network he used to download those data, and also the delay we have here. So he will find the best window size for him to transfer all those data. Thanks.